Good evening to everyone. My name is JASPREET Kaur. I'm here to present a presentation on low power differential delay ring VCO design in nanotechnology under the supervision of my guide, Dr. Vikram Singh. These are the contents. Here I discuss on my further presentation, introduction, literature review, CNT FET, VCO, proposed designs, result and discussion, conclusion, and then references. First, we talk about our project objective. This research paper presents a review on performance comparison of different types of voltage controlled oscillators to analyze power dissipation and frequency response. The technology we used here is 45 nanometer CNT FET, which are we designed so many designs on based upon VCOs. The performance of different circuits at transient response, frequency response, and power has been comparatively analyzed through different simulations.
This is Atvaran.
First, talk about what is carbon nanotubes. These are the allotropes of carbon with a cylindrical nanostructure. It is synthesized with the length into diameter ratio because of its extraordinary strength in electrical and thermal properties. And one more important advantage is that it is flexible without any damage. It is a structure of carbon nanotube. It is like a hexagonal shape. Where one of our researcher also discussed with you the types of carbon nanotube, single wall, multi dot, but it is a single wall nanotubes which are a form of cylindrical hexagonal shape. It is to bond it together to form a carbon nanotubes. These are the latest strength of nanotechnologies from 2003. It's 90 nanometer, after 2005 65, and 2070 45, and after that after now it is on 4 nanometer. The researchers are going to work on the 4 nanometer technology. Advantages is this: less pollution, low production cost, technology itself, and low power consumption. The main motive of designing these tubes is the low power consumption. These are my literature review. We've gone through our research from 2001 to till 2021. We go through many research papers, his design, because most of research is based upon the CMOS technology. But in my research, we are going to CNT FET technology for making the carbon nanotubes instead of silicon, we are using CMOS. First, we know about what is CNT FET. Is the carbon nanotube field effect transistor, is a 3-terminal device same as MOSFET we are using in our phones, electronics. Many of us are using medical field also. Same structure, but one of the advantages is that the heat dissipation, thermal dissipation is very less in CNT FET as compared to MOSFET. Size is also very less as compared to MOSFET. That's why we are using CNT FET technology nowadays in very good manner. Principle is like the basic principle of CNT FET is same as MOSFET, where electrons are supplied by the source terminals and drain terminal reflect this electron. And this current is flowing through the drain to source terminal. The gate terminal control the current intensity in the transistor is in off state if no gate voltage is applied. The main objective of my paper is a voltage control oscillator, where we design voltage control VCO on this technology, because it is an important part of the VLSI because of its frequency is controlled by the input voltage. The ranges is from few hertz to hundreds of gigahertz. We can see the frequency and the voltage is usually it is a simultaneous linear. When the voltage changes, automatically frequency is changes. After this principle is same, it is based upon the charging and discharging of the output mode of parasitic capacitance present at the output terminal of the CNT FET inverter. Easy to implement, better stability. The one is low power and thermal dissipation we are required for designing these VCOs. Research gap of mine is that there would be a explosive requirement of efficient system device in respect to the desired result, with a trade-off between the transistor sizing, frequency, speed, delay, and power consumption of the circuits. Here we design so many proposed designs: CNT FET inverter, ring VCO, differential ring VCO, skew delay VCO. All of these are based upon the nanotechnology, that is CNT FET inverter based technology. These are my first design. We are using CNT FET. These are PCNDFT or NCFT. These designs are the main principal design for designing our VCOs. This is their capacitor for charging and discharging of the capacitor. Here we get this type of inverting because it is an inverter. So we get the output in inverting form. As we see there in the waveform, we get this output. Next, we design ring VCOs because produce an output signal whose frequencies vary with the voltage amplitude of the input signal over a reasonable range of frequency. Frequency stability with reference to power supply voltage, noise, and temperature. One of the most important is accuracy in the control of frequency. Here is a design with the help of CNT FET inverter. We are designing the ring VCO. These are 3 delays of designing the VCOs and the capacitor. We have already told you in the inverter, in the basic inverter circuit, there is a capacitor. So in this design, we also use a capacitor for charging or discharging our system. Next, the main design of my research paper is differential delay ring VCO. It is a basic principle is same as that ring VCO we have previously discussed with you. It has minimum power dissipation we are required nowadays. Rise time and fall time of the output get reduced, which increase the oscillation frequency. The frequency range we have been seeing megahertz to 1.1 gigahertz. Useful for high frequency applications in our mobile phones. We are using this type of VCOs for the speed of the processor. Here we implement this design with the help of the software. These VCO, differential VCO, these are 3 delays, same like ring VCOs, but all the difference is that the output of first delay is the input of the second delay. And same as second or third delay, the output of second delay is the input of third delay because we get the out of phase waveform for the results. So we connect the connections like that because we get the output we saw in VCO, we get that sawtooth or triangle waveform. Here this also a form of sawtooth because all the cycles are say out of phase. One cycle, inverted second cycle, second and third, all these are in the proper manner. We get the output result. There's another delay is called skew delay because the rise and falling time mechanism of the output signal are somewhat different from the design we are doing in differential is same like, but there is some slightly difference. We high operating frequency for wider tuning rate, same low power consumption, offer high speed operation with faster settling time. It is designed, but it's little simple as compared to differential, but same inverter CNT FET we are using, but there is a no delay in this circuit. But in differential, there is a delay we are giving in 3 cycles, but in skew we not give any delay of it. The output we get from this VCO is here. These are my comparison table. All the proposed design we design is frequency, tuning range, voltage, current, power we get from our output result. I'm showing to you. Conclusion is that increase the frequency tuning range. Second one is reduce the power supply, satisfactory speed of operation, and third last one is simplicity of design. Future scope is now nowadays electronic market is going with huge space. Huge number of electronic devices like mobile phones, functionator, etc. are deployed with the help of VCOs. But the security of power ki kami is going to be a big problem. Power efficient VCO will be proved to be great step in this direction of power saving, as it will help in minimizing the power losses. These are my references we are studying for my research. Thank you from my side.
Thank you for your wonderful presentation.